Hello guys. Today I'm going to walk you through my project. Okay, the problem statement for this project is use clustering algorithm to segment customers based on their purchasing behavior so as to understand the different types of customers and tailor our marketing strategies to meet their needs. Okay, let's begin with importing some necessary libraries. Okay, so I'm going to import pandas to use, basically pandas is used for data manipulation and analysis. Then I'm importing NumPy for numerical calculations, to deal with arrays and matrices. I'm importing matplotlib. It is used to create plots and graphs for visualization. Then the sklearn library. It is used for implementing machine learning algorithms. So from sklearn library, I'm going to import KMeans and standard scalar. KMeans is for clustering and standard scalar is used to scale all the features so that they contribute equally while we are performing our clustering. Okay, then I'm also going to import warnings because it is going to help us to manage our warnings that sometimes arise during execution. It basically is going to help us to maintain a clean output. Okay, so let's load our data set. Okay, I'm going to use the read CSV function to load a data set from the CSV file into a pandas data frame. Let's have a look at it. We have first we have an ID column. It's basically it is a unique identifier for each customer. Then we have age of the customer, the gender, their income, the spending scope, membership years, the purchase frequency, their preferred categories, and what was the last purchase amount. Okay, let's perform some basic operations on a data. So shape, it is going to tell us the number of features and observations that we have in a data set. So we have 1,000 observations and 9 features. Observations and features are nothing but rows and columns. Okay. Now info is going to give us details about a data set, like what are the columns and what data type is assigned to each column, like ID is integer, whereas gender is object or character data type. And then purchase amount is float, that is in decimals. And what are the null count in each, null values that are present in each column. We have 1,000 entries and it says 1,000 non-null count, which means that there are no null values in a data set. Okay? So describe is going to give us the statistical summary of a data. Like, and it is only used, it gives the statistical summary of our numerical columns only. So we have count, it tells the count of each column, the mean, their standard deviation, the minimum value, the first quartile value, the median of each column, the third quartile value, and the maximum value in each column. Okay, we already know that there are no null values. We found it through info, but just to check, we are going to use the isNull.is, dot sum function. It each column and give this. So 0, 0, 0, 0, which means that there are no null values present in any of these columns. Okay, so we can proceed with the. Okay, now I'm going to drop the ID and the preferred category column because I don't think it may be useful. ID is just unique identifier and preferred category won't really be useful in our analysis for clustering. So I'm just going to drop them to avoid any unwanted noise. Okay, let's have a look at it once we have dropped. So you can see here the ID and preferred category column have been dropped, and now we have these columns. Uh, we have the gender column, which is a categorical column, and for our clustering, we are going to need all numerical columns because we will have to scale the data before it, and for scaling, we need all the columns to be numerical. So we will uh, convert our gender column into a numerical one. For that, I'm going to use one hot encoding. So it will convert the gender column from a categorical to numerical one and create 3 different columns named as gender female, gender male, and gender other, and assigns true or false values, which is like zeros and ones. It's binary values. Now, once we have converted, let's see if any null values have been created. So we can have a look at values in our data set. So we can begin with the scaling process. Okay, for scaling, scaling is basically used to transform a data so that each feature has a mean of 0 and a standard deviation of 1. So just in case if any feature has a larger value than the others, like income in a data set, we can see, and the spending score or the membership years are very less in terms of income. So when we have values like this, they may dominate the clustering process. Therefore, we scale the data to ensure all features contribute equally. Okay, the scale data is always stored into an array. So we are going to convert it into a data frame for easier manipulation. Okay, we can see how each data is represented here. It is converted into some numbers. Okay, so basically this is scale. Now we are going to apply the elbow method by running the k-means for a range of cluster numbers from 1 to 10 and calculate the WCSS, which is called as the within cluster sum of squares. This loop runs the k-means clustering, for the different values of clusters, and then stores the inertia for each cluster value. Inertia is nothing but it is the sum of the squared distances between the points and their centroid. Okay, let's plot the elbow graph and see. Okay, this elbow curve, it is going to help us to identify the optimal number of clusters. In my case, in my project, for this particular project, it is 4. You can see the bend here. Okay, so my optimal number of clusters, what I found to be is 4. So I'm going to use this and, cluster. So we assign each customer to one of the 4 clusters and store it in a new column named cluster. Let's have a look at our data. Now you can see there is a new column created here named as cluster. And 4 clusters have been created and each customer is assigned to a particular cluster. Like the first customer has been assigned to cluster 2. Okay. Now let's is the cluster. Okay, this is a scatter plot that is going to show how customers are grouped based on their income and the spending score. And this black dot over here, it represents the centroids. Okay. Now let's summarize. I'm going to use the group by function on the cluster column and cluster it based on and group it by their means. Okay. It is going to just provide us insight about the average income and the average spending score to help interpret the difference between the customer groups. Okay, like have a look here. Blue is cluster 1, yellow is cluster 2, while green is cluster 3, and red is cluster 4. Now, blue shows us that whenever the income is high, the spending score is also high. And have a look at yellow, the income, have a look at yellow over here. The income is relatively, it's moderately high, whereas the spending score is also okay. Then we have green, which is spread equally basically. So they have varying spending score based on their incomes. And then red, we can see it mostly in the first part of this column, which means that they have low income but varying spending scores. So using these insights, we can offer recommendations like we can offer premium offers to high value customers like the customers in blue, the cluster 1, and we can offer discounts to low value customers like our customers in red and green.